Alrighty guys, here we go. So this is what your homework is going to look like. So you're going to be asked to find the vertical asymptotes, if there are any, the horizontal asymptote, again if there are any, and the holes for a function, okay? And keep in mind that any one of these features may not exist for a particular problem, so it's okay to say that there isn't any of these things, but each problem on your homework will have at least one of these three things involved, okay? Now the function you're looking at here is already factored for you. On your homework, some of the problems will be factored, others will not. So step one is always to factor if it's not already factored. Okay. Now you can do the horizontal asymptote right from the very beginning if you want. So in order to do that, what you want to do is you want to figure out, well, what's the leading term for the numerator and what's the leading term for the denominator, okay? So think of it like when we were trying to figure out the leading term for graphing a polynomial function, sorry. So I'm doing, for the numerator, 4x squared times x times x. So again, that's 4x squared times x times x. That comes out to 4x to the fourth. In the denominator, I'm doing 2x cubed times 3x times x. And that comes out to 6x to the fifth. And again, we don't need to multiply the whole thing out. We just need to know what's the leading term in the leading term. So multiply all the variable parts together. All right. Now, if I look at this, if I compare the exponents, 4 on the top, 5 on the bottom, that's bottom heavy, or a bigger degree on the bottom than it is on the top. That tells me that horizontal asymptote is at y equals 0. Okay. So that part you can usually do pretty quick and easy from the very beginning. And if it's in standard form on the top and bottom already, it's even easier. Okay. Next up is identify your domain restrictions, because those are the places where you could have holes in vertical asymptotes. So the domain restrictions here, since there are 3 factors in the denominator, there are 3 domain restrictions. From 2x cubed, I get the x cannot equal 0. From 3x plus 7, I get x cannot equal negative 7/3. And from x plus 1, I get x cannot equal negative 1. Then we want to look at, well, what reduces here? And this is where you've got to be careful. Okay, the x plus 1s are easy to see that they cross off. Then you've got a 4x squared and a 2x cubed. So 4 over 2 is a coefficient of 2, which you see up top. And then x squared over x cubed, those mostly reduce off, but there will still be a single x left in the denominator. So that's where my single x down here in the denominator came from. All right? The x plus 1s are gone, and I'm left with an x minus 3 up top and a 3x plus 7 on the bottom. So this is the simplified version. Now this simplified version still has 2 domain restrictions at x equals 0 and x equals negative 7/3. The remaining domain restrictions are always vertical asymptotes, because no matter what I do, I'll never be able to plug these numbers in because they don't simplify off, okay? So 2 vertical asymptotes. Because they're vertical lines, we always write x equals these 2 numbers, never y equals, always x equals, okay? Vertical asymptotes, always x equals. The factor that crossed off, the x plus 1s that we had at the very beginning, that's where the hole comes from, okay? So I have a hole at x equals negative 1. So I need to figure out, well, what is f of negative 1? What's the y value there? So I'm plugging negative 1 into the simplified version in green. That's what you're seeing down here in purple. So I'm doing 2 times negative 4 is negative 8. And the bottom I have negative 1 times positive 4 is negative 4. So that gives me a y value of 2. So the hole is at the coordinate point negative 1, 2. And this is about how much work I would expect to see on your homework. The only thing that might take a little bit more time is if you have to go through and factor to start off. Okay, so you are identifying horizontal asymptotes, vertical asymptotes, and holes. All right, guys, good luck.